A very good morning to all of you children. In last class, we have discussed two important activities, activity 13.8 and 13.9. In activity 13.8, we have seen that whenever there is a relative motion between a magnet and a coil, a current is produced in the coil, and this current is called induced current, and the phenomena is known as electromagnetic induction. There is another way of producing current in a coil, that is in activity 13.9 we have seen that by changing magnetic field we can also produce current in secondary coil. And I have given questions. The first question was, explain different ways to induce current in a coil. Question 1 was, explain different ways to induce current in a coil. So you in answer you will write the different ways are, first write down so the two different ways are by moving a magnet around a coil and second by changing magnetic field around a coil. So how we are changing the magnetic field? By starting or stopping the current. We are changing the magnetic field around the coil, and so some magnetic field is changed around secondary and some current is produced. Here you can add or vice versa. By moving a magnet around a coil or inside a coil, or when magnet is held stationary and we move coil, then also current is produced. So this is answer of first question. Now question number 14. Question number 14 was page 241. Question number 14. The question was, two circular coils A and B are placed close to each other. If the current in the coil A is changed, will some current be induced in the coil B? Give reasons. So the answer is yes. Then you will write when the current around coil A, around the coil A is changed, the magnetic field around it also changes, and hence the magnetic field lines around the coil B changes, and so current will be induced in the coil B. So write this answer, children. I think you all have written. Now we will discuss Fleming's right hand rule. Very important rule. Fleming's right hand rule. So first of all, we will discuss what is the role of this rule, why we are reading about it, what is the purpose. So, right hand rule. Earlier we have discussed Fleming's left hand rule in electric motor. In Fleming's left hand rule, we have learned that if we stretch our middle finger, forefinger and thumb of left hand in such a way that the middle finger indicates the direction of current, the forefinger indicates the direction of magnetic field, then thumb gives the direction of motion or direction of force. Now in Fleming's right hand rule, just you have to stretch your middle finger, thumb and forefinger of right hand. So it is important to note that you will stretch the three fingers of your right hand. Now if the middle finger, or you can say, if start from forefinger, if the forefinger indicates the direction of magnetic field, as usual in Fleming's left hand rule also the forefinger indicates the direction of magnetic field, the thumb indicates the direction of force, then the middle finger will indicate the direction of induced current. And so with the help of this rule you can find out the direction of induced current. So what is the purpose of this rule? So you will write, with the help of this rule we can find out the direction of induced current. Write it. So the purpose is that we can find out the direction of induced current. Now the statement. Because sometimes you can get question to state the rule. So write down the statement. According to this rule, if we stretch our forefinger, middle finger and the thumb of our right hand in such a way that the forefinger indicates the direction of magnetic field the thumb indicates the direction of force or you can say motion, then the middle finger shows the direction of induced current. So very important rule. As I have written, according to this rule, if we stretch our forefinger, middle finger and thumb of our right hand in such a way that the forefinger indicates the direction of magnetic field, the thumb indicates the direction of force, then this middle finger will show the direction of induced current. Now electric generator is based on this principle, but for this year generator is not in your syllabus. So our course is almost complete, children, and from next class we will revise through the board questions. And I think examinations will be held in time. Now you must be serious because CBSE will take the board examination in time and it will be offline. So now serious preparation is needed because now it is November. Now hardly 2-3 months are left for the exam. And if you make a timetable, I think you will get 15 to 20 days for a subject. So be serious. If you have any doubt, you are free to ask anytime. I think you all have written. Now giving a board question, or we will discuss a board question. So this question was in 2018. You see, it is 5 marks question. It is 5 marks question. State Fleming's left hand rule, then write the principle of working of electric motor, and then you have to write the function of armature, then brushes and split ring. So very important question. Five marks question. First part is state Fleming's left hand rule. Write the principle of working of an electric motor. And third part is explain the function of the following parts of an electric motor. First, armature. Second, brushes. And third, split ring. Write down the question and then we will discuss the answers. So children, Fleming's left hand rule we have discussed earlier. You have to write a statement for it that when we stretch the middle finger, forefinger and thumb of our left hand in such a way that the middle finger indicates the direction of current, the forefinger indicates the direction of magnetic field, then thumb indicates the direction of motion of conductor or force. Then write the principle of working of an electric motor. That also I have given in the last class or day before it, that a motor is a device which converts electrical energy to mechanical energy. When a rectangular coil is placed in a magnetic field, a current carrying rectangular coil is placed in a magnetic field, it experiences a force and the direction of force is determined by Fleming's left hand rule. So that you have to write in the principle. Now these portions which we have not discussed, I have sent a link of a video. So armature is a rectangular coil. So a rectangular coil is a piece of soft iron and we wrap as copper wire over it. Several turns of wire are wrapped over it. So when we pass current through the armature, armature means a combination of soft iron core and the copper wire which are wrapped over it. So suppose this is the soft iron core and we have wrapped rectangular obviously, and we have wrapped the copper wire over it. So this hole acts as a armature, and this armature is placed in a magnetic field. When we pass current through the armature, it experiences a force, and due to this force it starts rotating, and ultimately it is connected with a shaft. So when the armature rotate, the shaft also rotate, and when shaft rotate, shaft is connected with wheels, sometimes fans. So you can say that the electrical energy is converted into mechanical energy through the armature. So write about it, children. First, the armature, right? The armature converts, write down, the armature converts electrical power to mechanical power, electrical power to mechanical power, and transfers it via the shaft, and transfers it via the shaft. Then the function of carbon brushes. So second, brushes. So as we have discussed in motor, that there are two half rings known as split rings, and these split rings are insulated from inside, but the outer surface is the conducting one, and they are connected with two stationary carbon brushes, and the name of brushes in your book, I think they are X and Y are the brushes, and P and Q are the split rings. And these carbon brushes are stationary, and they make contact with the rotating rings. So write about brushes. Write down the function of brushes. The function of brushes is to make contact, is to make contact with the rotating rings, with the rotating rings of the commutator, rotating rings of the commutator, and and through them, and through them to supply current, to supply current to the coil, supply current to the coil. Then you have to write about split ring. Split ring or commutator, same thing. So as I have discussed, the split ring are responsible for reversing the direction of current after every half rotation of the rectangular coil. So write about split ring. Write split rings reverses split rings reverses the direction of current reverses the direction of current after every half rotation after every half rotation of the coil after every half rotation of the coil. So in this way we have discussed an important question which was asked in 2018, 5 marks question it was. It was of 5 marks. Now I will discuss some other questions from NCRT exemplar. I think you all have written. Now next question. For this question you have to draw a diagram. Suppose there is a conductor through which I current is flowing. There is a point P here and this distance is R2 and there is a point Q here. Now the question is, AB is a current carrying conductor. So AB is a in the plane of of the paper as shown in figure. What are the directions what are the directions of magnetic field produced by it? At points P and Q, given R1 is greater than R2, then write where will the strength of the magnetic field be larger. So AB is a current carrying conductor. Suppose the conductor is in the plane of paper. So suppose the book or copy which you have kept now on your table, on that table the wire is placed. So what are the directions of magnetic field produced by it at point P and Q? So P is right side and Q is towards left side. So to find out the direction of magnetic field, which rule we will use? Think over it. We will use Maxwell's right hand thumb rule to find out the direction of magnetic field. So suppose we hold wire in this way, because the wire is in the plane of paper. So if we hold in this way, that the thumb indicates the direction of current. This is the direction of current, and the fingers wrapped around it shows the direction of magnetic field. So the magnetic field will be like this, isn't it? So it appears on the plane of paper that it will be onto the page, or you can say that it will be onto the plane of paper. Then the left side is Q. So that side it will be just out of it. So it will be, suppose this is the plane, okay, and you have placed a wire over it. So if we hold it in this way, that the thumb is in upward direction and the fingers are wrapped around this, so it will be into the page, right side, and these magnetic fields move and goes up then. So it will be move and goes up, so from Q side it should be outside. So here you will write into the page, and from left side you will write it will out of Q. It means they are moving in this direction. So it will be into the page and then moves, and it will be coming out of Q. So these are the direction of magnetic field. Towards P it will be into the page, and towards Q you can write it will be out of Q. The magnetic field will come out of Q side. Then given that R1 is greater than R2, what will be the strength of magnetic, where will the strength of magnetic field be larger? So as we move away from a current carrying conductor, the strength of magnetic field decreases, and when it will be close to the conductor, then magnetic field will be larger. So you will write that the strength of magnetic field is larger at the point located closer to it, that is Q. Magnetic field will be larger at a point which is close to the conductor, that is point Q. So I think it is clear to you children that how it will be into the page, and how from Q side it should be outside from the page, and why magnetic field is larger at point Q, because this point Q is close to this conductor AB, and it is given that R1 is greater than R2. It means R2 is close to this current carrying conductor. That's why magnetic field will be large here. And as we move away from the conductor, the strength of magnetic field decreases. So this much for today, students. In next class, we will discuss some more interesting and important questions, because now we will start our revision, and for second term, uh, electric current, electricity is coming, and magnetic effects of electric current, these two chapters are coming. So we will revise the chapters thoroughly. Thank you.